Send me your answer once you feel correct. So work done by the thrust equals to gain in potential, gain in kinetic, and heat. But because this is power, so entire equation have to divide by time to change to power. Okay, you have to divide by time to change to power. So efficiency of the process. Efficiency is what? Output power over input power. Okay, so I'm receiving answers ready. Okay, so variety of answers this time. B, D, A, and D. Majority, I think, out of 4 answers I received, 2 go for D. 2 go for D, 1 go for A, another 1 go for B. Okay. Come on, think another 1 minute. So nobody gives me the answer C. A, B, D is there, but 2 of you say D. Many say D. Okay, how to do these questions? It's the efficiency. Efficiency. You want the efficiency when the car goes up. Efficiency means what? Output power over input power. Okay, last time I told you, which is the output power? Which is considered as output power? The useful output power. The car thrust did work, goes up. You as a driver, the whatever work done by the engine, you want that work convert to what form? Do you want it to convert to kinetic energy? Yes, right? You want to make it more faster one. So again, in kinetic energy is a useful output power. Okay. Do you want the work done by the thrust to gain potential energy? Yes, right? Because you want to climb what? You want to climb a hill. So you want to climb a hill, you want it to gain potential energy also. Potential energy means you are climbing hill, right? So potential energy also is a useful output power. The only thing we don't like to have is what? Heat. So heat is a waste. Okay. So the useful output power is the gain in kinetic energy and gain in potential energy is useful output power. Okay. So what is the input power? Input power is the thrust. The work done by the thrust, the input power. So let me open up the whiteboard. Okay, only got 4 answers. The others get idea. Okay, let me scroll this, put it at the side first, so that I can. Okay. Okay, class. You see, So what is the? This gives trouble here. Okay, you see, So work done by the thrust is equals to gain in EP, gain in EK plus heat. Okay, plus heat. Okay, because this given in terms of V, like in terms of V, so we put it in terms of power. Thrust is what? Force times S, F times S. F is the thrust, S is the distance traveled to the direction of force. Gain in EP is what? Gain in EP in terms of mg, how you can write? You can write mg, anyone? Mg sine alpha multiplied by S, right? Multiplied by S is the gain in potential energy. Or we can use mg times the vertical height. But here look like S is there. So we use the horizontal component of the weight times the S. This S. So that is the gain in potential energy. Okay, gain in kinetic is what? Is there any gain in kinetic here? Is it constant velocity? Constant force acting on the car through a distance of constant velocity. They say constant velocity. So because they constant velocity, so EK for sure is going to be 0. There is no gain in EK. And yes, they should have heat. Okay, this is the formula. Okay, so now we divide all of them with time. This is time t. This also divided by t. All divided by t. Okay, so you should know which is the output power. Which is the output power? This is your output power. This is your output power. The gain in potential is output power for this case. But in reality, not only gain in potential, gain in kinetic also. Gain in kinetic plus potential, this together is output power. But because in this case EK is no gain, so only the potential is the output power. Okay. What is the input power? The work done by the thrust. The power of the thrust. This is your input power. The input by the engine. Okay. So what is the efficiency? What is the efficiency? Output over input word. That means this divided by this is your answer. So mg sine alpha. Okay. So S over T. S over T is actually what? S divided by time. Is the velocity, the velocity going up. So S over T, we can pack them together, put it as V. Okay. So divided by FV. The ST here also V. This ST also V. So it's become FV. It become FV. So final answer VV cancel. So the answer should be mg sine alpha over f. Yeah, f. So the answer should be D. D should be the answer. Okay. So this is how the working should be. Okay. So sometimes we have to divide by time, put it in power form. Why I changed to power? Because I found there is a velocity here, V. Velocity involves. So how to create velocity is the S over T going to convert to velocity. To get the velocity, to change the S to become velocity, we have to divide by time. So we bring in time. So change to power. All the equation become power. Okay, anyone got any problem with this working? Any confusion? Do you understand? So it should be D. Okay, work done by the thrust equals to gain in EP, gain in EK heat. Gain in EP, gain in EK is the output energy. If you divide by time, it will be the output power. Useful output power. Useful. That's what we want. When you drive car, we want gain in kinetic and we gain in potential. This is your input power. Okay. Okay, so no problem. So should be D. Those who got D, good. Okay, the answer should be D. Okay, class. So before I continue the next question, I believe some of you have tried this paper. Do you have any questions first? Maybe you have questions. After if you don't have any questions, then I select mine. Anyone have any questions? Any page number? You have problem? Don't have? So if you have, just interrupt me. So I straight go to your questions. So by then I choose mine. Okay. So if you have yours, just tell me. Okay. So this is one question in inclined surface. Okay, this one. Question 14. Is the same concept. Give me the answer. Come on. This time, please, everyone, try to get the same answer. 1 minute for you. So what is the work done by the person? So work done by the thrust equals to gain in EP, gain in EK, heat. Okay. So they're asking work done by the person means they're asking work done by the thrust. Because the person is a thrust. So what is work done by the thrust? Is the gain in EP plus gain in EK plus heat should be work done by the thrust. Okay, the thrust causes the body to gain potential, gain kinetic, and also heat. Okay. So anyone got the answer for this? Please send me through WhatsApp. Hope all of you give me the same answer. Okay, so I got one answer. C. So only one send me the answer. The others? Is it all of you got C? C, yeah. Okay, 150 times 150. Is it C? The others also got C, yeah. Okay. Okay, I receive more answers. Okay, another one. Okay, many say D now. So one of you said C, two of you say D. So C or D? Okay, let's check. Okay, many D. So many D. Okay, let's go. How to get to this question? So as usual, let me go back. Okay, so as usual, work done by the thrust equals to the gain in EP, EK, and the same thing lah. EP, EK, and the thrust, heat. Sorry, I have to repeat this many times so that you really understand this. So because the person is a thrust, so we are looking for this work done by the thrust is what? Work done by the thrust. So gain in potential energy. Gain in potential energy is 200 times 1.5. In this case, because vertical height given, we straight away can use mgh. So gain in potential energy, we straight away use mgh. mgh. So in this case is 200 times 1.5. Okay, 1.5 is the gain in potential energy. So how much you get? You get 300. You got 300 joule. Okay, this is only the potential. Plus kinetic. Is there any rise in kinetic? Because they say steady speed. So steady speed, that means no gain in kinetic. So kinetic is 0. Okay. And heat, definitely there is a heat because they say there is a friction. Frictional force, there is a frictional force. Okay, so frictional force, how much? Frictional force is how much? 150 Newton. So this is the inclined surface. So friction acting downwards, 150. That means the distance you have to use is the distance along the parallel to the frictional force. So the heat generated is, of course, frictional force multiplied by the distance traveled parallel to the force law. So in this case, 0 for the kinetic. So F is 150, but the distance traveled how much? The along inclined, the distance along the inclined surface, but which we don't have. But vertically is 1.5. Horizontally, the height should be how much? Use Pythagoras. Sorry, not Pythagoras. Trigonometry, because this is 30. So vertical height is 1.5. It rises in. So how much this S will be? This is your S. So because we need to use this is the S and this is the S same. So how much is the S going to be? So it should be what? 1.5. 1.5. 1.5 divided by sine 30, right? Divide by sine 30, yeah? If you divide, right?
Yes.
Yeah, so 1.5 divided by sine 30. So you get what? You get 3 here, half 3, so you get 450. You get 450, yes, good. So the answer is D, so 750. Good, those who got D is good. So this is how the working should be. In this case, EK again becomes 0. So most of the questions, I think EK or heat becomes 0. Okay. So you have to check. When you know its heat becomes 0, when they say frictionless surface. When EK becomes 0, and they say constant speed. When the thrust becomes 0, when there is no thrust, like no engine, no car engine, no person pulling it, just act of nature is moving down, and then thrust is 0. Okay, EP0 when the gain in EP0 when it's moved in a flat surface. Okay, good. So any question from this? Hope everyone gets 750, majority getting 750. Okay, so no problem here. Okay, any questions? No questions, Okay. So please interrupt me if you have any questions. Any questions you like me to go through. Until then, I randomly move on. Okay, next. The following question. We go away from the incline. 15. Okay, page what? Page 32, question 15. Again, 1 minute for you. Get me the answer. So please WhatsApp me once you got the answer. Which expression gives the kinetic energy of the raindrop? The raindrop is falling down with the mass m, but there was an air resistance. There was an air resistance with a steady speed v. Air with a steady speed v acting up. The raindrop experienced a retarding force. Retarding force means force opposing the movement, like air resistance. So the force acting up opposing the movement is kV. K is constant, v is the speed. Okay. But the acceleration of free fall is g. Which expression gives the kinetic energy of the raindrop at that moment? Okay, so one of you said D. Yeah, this got D also. Is it D? It's moving with the terminal velocity. Force up should be same as force down in this case, right? Because moving with a constant speed, what? So force up should be equals to force down. They're asking for kinetic energy. Kinetic energy is, of course, we know half mv squared. So half okay, m okay, but v we need to replace. We need to replace in terms of k. That's the problem now. Okay, so many say D. So I believe should be D. All of you got D? Okay, I'll do this. All of you give D. Okay, so let me check. Okay, how do you do this? Because the raindrop is here, the force down is mg, the force up is the air resistance, which is in this case they put this as kV. Okay, kV, but it's moving down with constant velocity. It's moving down with constant velocity. Therefore, the net force must be 0. The net force 0. But we are looking for kinetic energy. Kinetic energy is what? Half mv squared. Half mv we need to replace. We don't know the v. We need to replace in terms of k. So we need to find the v first. How to find v? From the net force. So net force is 0. So that means force down mg should be k, same as force up kv. So yeah, we got the v here. So v is what? Mg over k. That's your v. So we substitute here. So mg over k squared. That's your answer. So it become what? Half. So it's going to be what? M cube g squared over k squared. K squared, yeah. That's good. So the answer is going to be D. It's under D. Okay. So because it's moving down, weight balance the retarding force. Because moving in the constant speed, net force must be 0. Mg equals to kV. So we find the V mg over k. We substitute into the kinetic formula. So you get the kinetic energy. Okay. So those who didn't get, hope you this working under should be explained to you. Any problem here? Okay. Yeah. Okay. So far so good. Majority giving me the correct answer. Okay. So let's proceed. We try more questions. Okay. Okay, this question, 12. This is yeah, part B. Part B means I jumped the years lah. This is 2015 year paper. May June, paper 11. Okay, come on, give a try. 1 minute for you. Work done by the thrust equals to gain in EP, gain in EK, heat. Yes. Hope everyone give me the correct same answer. Wrong number, just give a try. Send me first. This time they're asking what is the frictional force F? The universal law always there. Work done by the thrust equals to gain in EP, gain in EK, heat. From there, you can find the friction. Heat you expand, it becomes force times distance. So the force we are looking for. Okay. But here, slash down in acceleration. It's moving down with acceleration. Gain in potential acceleration. So there is kinetic, there is potential also. Oh, this is tricky. What is the frictional force? Oh, this is only the force one. This is only the force law. Oh, I think this, I thought this going to be typical. It's an easy one. Okay, some of you, I receive answer. Some of my friends say it's C. Oh, so okay, many say C. Yeah, is it C? I thought it's a difficult one. This one is quite easy. C mg sine theta minus A is your frictional force. Yeah, so because inclined surface, friction is acting up. We go in terms of force law. The force acting down is the mg sine theta. Mg sine theta, the force acting down. That's all. But finally accelerates down. Okay. Okay, I think this is straightforward. What? The thrust, but the thrust minus the thrust. Here don't have thrust. To be, so force down minus force up is MA. So mg sine theta force down minus friction up should be equals to MA. Yeah. That's it. Okay, no thrust involved here. There is no thrust here. Thrust is 0 lah. So make the A as a make the F as a subject. Then you got the answer. So mg sine theta minus MA. Minus MA will give you the frictional force. Okay, so I think the C is answer. So take the mg out. So G sine theta minus A. So those who got C is good. This time I think no issues here. Everyone got C. So I think this question is quite easy. Just the net force. Force down minus force up is MA down. Okay, we can take like downwards as positive. Big force minus small force is MA. Okay. Any questions from here? Anyone? You get the answer. Okay. We proceed more. Okay. Okay, let me another one. Okay, class, this one, 15. Sorry. Yeah. What page is this? Just for you. This this page 34. Page 34, question 50. 1 minute for you. What is the change in gravitational potential energy of the block? Okay, so I'm receiving answer B. Everyone got B. Is it B? I receive only one answer, B. All of you got B? Okay, let me give you a clue here. Oh, yeah, 2 of you said B. 0.6, 0.9, 0.9 times. Is it B? Hey, class, let me give you a clue. Then you think, I give you a clue. The clue is, this. Okay, 2 of you say C. 2 said B, 2 say C. Which one? Okay, let's say the clue is this. Let's say you stand. Okay, you stand here. Let's say, okay, you have a block. I go to the block. There is a block, a uniform block. Height is 1 meter. Height is 1 meter. It's a cube. It's a cube. It's a cube. Okay, a cube. So height is 1 meter. Width is 1 meter. Okay, length is 1 meter. Okay, box. Okay, I'm asking. The weight is let's say 1 kilogram. Okay, what is the potential energy possessed by this body? So mgh, right? Okay, so m is 1 kilogram, g is 9.81, h you use how much? H you use how much? It's 1 meter height. It's a cube. H you use how much? H you use? Anyone? 0.5. H you must use 0.5. Yeah, center of gravity is the one counted. Gravitational potential energy, the height is always counted from the center of gravity. From the center of gravity, not the top. Where the center of gravity lies, that's the height counted. Okay. Okay, now answer is B or C. For this object, you see, the body is on top here. The body is here on top. It was how much? It was 0.6 meter. That means center of gravity is at the center here. So it's about how much the center of gravity initially is 0.3 meter. Okay, higher than the ground. And then after that, it's fall back here. Here, where's the center of gravity now? Center of gravity is here. About how far away from the bottom? How far away from the bottom, because it's 0 forward. So center of gravity must be 0.2 meter above, 0.2 meter above. So it is the center of gravity here. This has 0.3 meter. What is this distance? This distance? This distance is 0.6, right? This should be 0.6. So conclusion, from here to here, this is the height you're supposed to use. Okay. So the height is how much? 0.6 plus 0.3. So the height should be how much? The height is actually 0.9. 0.9. Okay, so that is the change in potential energy. The change in potential energy is mg h. So here mg is how much? Mg is where's mg? It's mg. Mg is 500. Okay, mg is 500. So 500 is your mg. Okay, then h is 0.9. So you get what? You get 450. So you get 450 joules. Good. So those who got 450, very good. So something learned here. The gravitational potential energy, the height only measured from the center of gravity. Okay, from the center of gravity. So the answer should be C. Okay. Any problem here? Anyone got problem? So hope you understand. Center of gravity is used to find the potential energy. Okay. So let's move on. More questions? I've got another inclined surface here. Okay, this one. 39, 30, page 40, question 16. Hope everyone give me the same answer this time. Give a try. Work done by the thrust equals to gain in EP, gain in EK, heat. What is the energy dissipated by frictional force when the car moves from X to Y? That means heat. They're asking how much is the heat. So the car got thrust or not? Car's brakes are released. So receive answer. So B, if you said B. So all of you got B. The car brakes are released and the car rolls down the slope with its engine switched off. Okay. So do the car has thrust? Engine switched on what? So no thrust lah. So no thrust. And this work done by the thrust is 0 lah. So for the first time, yeah, in this case thrust is 0. Although it's a car, engine is switched off. So is there a gain in EP? Yes, there is a gain in potential energy, but negative, right? In the formula, you must put a gain in EP as negative lah because it's going down. Is there any gain in EK? Yes, gain in EK is there. The gain in EK is positive. Final kinetic energy minus initial kinetic energy. The gain in EK. Is there any heat? That's what we're looking for. Okay. So I got another one said C, one said B, another one is said C. Come on, guys. I need more answers. B or C? The third person who are going to submit, I think, should be should follow the majority lah. Anyone? B or C? Work done by the thrust is 0. Gain in potential is negative. Okay, so 2 of you going for B. So looks majority going for B. Yes. Out of 4 answers, I received 3 B. Is it B? Okay, let's check. Let me show the working. Is it B or C? So work done by the thrust equals to, as usual, gain in EP, gain in EK, and heat, gain in Ek and heat, sorry, heat, okay. Thrust is 0, so no need to tell thrust is 0. Gain in EP is negative. It's negative mgh. Why negative? Because potential is dropping, negative. This is gain what I told you always. That's why I always stress this is your gain. The gain here is negative, so it should be negative lah. So potential energy I put negative. Negative mg. Mg how much? 500. So 500. Your m only 500. Your gravity is 9.81. Your h is how much? H is 30. So it's 30. Okay, but it's negative. It's negative. Plus kinetic energy. Kinetic energy is there is a gain. Kinetic energy is the gain of kinetic energy is the final kinetic energy minus the initial kinetic energy. That's your gain lah. Gain. Final and sorry, initial. I put I. Initial kinetic energy is the gain. And of course, you have the heat. Okay, the question looking for heat. You are looking for heat. Okay, so 0 equals to this answer, potential energy value, plus gain in Ek how much? Initial Ek is 0. The final Ek is how much? M is how much? 500 times V is how much? V is 11. 11. So 11 square lah. So 11 square. Okay. Okay. Plus heat. Yeah. So potential energy is negative. Potential energy is negative. Please calculate this for me. Please calculate this for me and put it here. This value, can you put it here? So potential energy negative plus the kinetic energy. If you bring these to the other side, so make the heat as a subject. If you take heat as a subject, I think the potential energy become positive. The potential energy will become positive. The kinetic become negative. The kinetic become negative. Yes. So potential minus kinetic is your heat lah, finally. Okay, please calculate those who got a different answer. Do you get you got B? Okay, you get B. MGH how do you got? 500 times 9.81 times 30. It's around 500 times. How much you get? 500 is 5,000. 5,000 is
147150.
Oh, okay. For MGH only,
Yes.
MGH 147.
150.
147 150. 150. Your gain in kinetic how much? Kinetic how much?
30250.
30250. 250. So finally, what do you get? B is it?
Yes.
D. So you get 1.2 times 10 power of 5. Okay. So B is the answer. But please hope you understand the flow. Always start with thrust, EP, Ek, heat. In this case, EP is negative because potential dropping. Something new. Normally goes up, but this case goes down. Kinetic energy is final minus initial. Initial is 0, final got value. So kinetic energy gain is positive. We are looking for heat. So good. Answer is B. Okay. Any questions from here? No, Okay, let's move on. Another one question. Okay, this one. 17. This is page 42. Okay, class, this is a flat surface. You can still use the thrust equals to gain in EP, gain in Ek, heat. It applies. Not only for inclined surface. For flat surface also that formula is applied. Only thing is what? The potential energy is going to be 0 lah. Okay, give a try first. 1 minute for you. Hope everyone give me the same answer. The object 15 Newton is pulled along the horizontal surface. 15 Newton is pulled along the horizontal surface with a constant speed, constant velocity. Force pulling the object 12 Newton 30 degrees. The force was inclined. But work done by the thrust, the force and distance travel, the force and distance travel must be parallel, same direction. Please consider that. The force and distance travel must be same direction to find the work. So in this case, the thrust is what? 12 Newton, but 12 Newton is inclined. Okay, I receive answers ready. B. One of you said B. Okay, the others, please give a try. Put your answer. Okay, only 4 or 5 of you trying. The others, come on, please. Give your answers. Wrong, never mind. Just give a try. It's a learning process. So work done by the thrust equals to gain in EP, gain in EK, heat. What is the power used in the move the object? The power they are looking for is which power? Input power, output power. The power used to move the object. That means the input power lah. The power of the thrust. The question asking for the power of the thrust. Okay, 2 of you said B. Okay, this time 2 of you said B. Okay, many giving B. Yes, 3 of you said B. Good. Okay, let's check. Is it B? Oh, good. Many, all of you said this time quite standard. All of you giving B. Okay, let's see. So the body here. So you apply a force here. We know this is the thrust. This is your thrust. Okay, the thrust. Okay, the thrust is 12 Newton. So work done by the thrust is EP, EK, gain in EK, EP, EK, and heat. Okay, because the question asking for power, so we have to divide by time. No choice. All divide by time. All divide by time. Okay, all divide by time. But the question asking for what? What is the power used to move the object? That means they're asking for the power of the thrust. This is the question. They're asking for the power of the thrust. Okay. So the power of the thrust. The thrust work done over work done. Okay, yeah, work done. You have. This is the speed given. What is speed? So speed is 2 meters per second. Okay, 2 meters per second. Okay, so I think no need to go for this 3 lah. I think straight away we can use this formula only. Thrust is what? Force times distance travel over the time taken. The distance I'm going to use this distance lah. The distance S is this distance. Is the S I'm going to use horizontal. So therefore the force, we have to resolve the force down because the force and distance must be parallel. So the force here should be 12 cos 30 because you close the angle. So force must be 12 cos 30. 12 cos 30. 12 cos 30 times S over T. S we don't know how far it moves, we don't know, but we know S over T we can pack together, become what? Become the speed, the horizontal speed. So S over T is actually V times V. That's it. That's all the answer. So 12 times how much? 12 times speed how much? 2. So 2 cos 30. That's your answer. So 12 times 2, 24. 24 cos 30. Do you get 20.8? I believe you got 20.8 lah. Okay, good. The answer is B. This is B. So in this case, we need to go for, we know the EP is 0, no gain in EP. EK also 0, no gain in EK. That means that is all are generating to heat lah. So whatever work done by you, the power, actually the question is power, is equals to the rate of heat dissipation. Let's say this question, instead it said, what is power used to move the object? If the question replaces it, what is the rate of heat generation? What is the rate of heat generation? The answer going to be the same, 20.8. Okay, because whatever work done by the power of the thrust is exactly same as rate of heat dissipation in this case, because no EP rise, no EK rise, all the work done to pull the object is converting to heat. So just in case, like I'm saying, what is the rate of heat dissipation? Question comes out. In this case, rate of heat dissipation means heat over time is also same as the input power. Yeah, so it's 20.8. Okay, good. So these are the questions you should do. You have plenty of questions in this paper work done. Okay, my advice is every topic after we done, I believe at the background, please do these questions and be prepared for your coming exams. If you have any question, you can WhatsApp me. Okay, I can use the online class to explain to you or through the WhatsApp. Okay, so next class tomorrow we'll be starting with the new topic 7, deformation of solid. Okay, so this topic I'll leave it to you. Do more questions. Try to finish these papers questions. Okay, yeah. So any questions so far? Okay, no questions. No questions, everyone? So if you don't have questions, so then we stop today. So I see you tomorrow. Tomorrow 11 o'clock, right? Tomorrow will be a new topic. Okay, see you. Thanks.